Hi, welcome to this video. In today's video, we are going to evaluate this limit as x is approaching to 0 from right hand side. We have x multiplied by natural log of x. Okay, let's evaluate this limit by plugging the 0 into x. What's the limit is? So the limit of x, natural log of x, as x is going to 0 from right hand side. This limit is 0 multiplied by natural log of 0 from right hand side, which is 0 multiplied by minus infinity. This is indeterminate form. What indeterminate form reminds you? Reminds you to use the Hôpital theorem, okay? So you have two conditions in order to use the Hôpital theorem. First condition, you have to have both functions are differentiable, and also the form f of x over g of x, as x is approaching to 0 from the right hand side, equal indeterminate form as well. So both conditions make you to use the Hôpital theorem. So, but in this case, we don't have a fraction of x over g of x. We have products. We have x multiplied by natural log of x. So how to make this form transferred into a fraction? Let's make substitution. So let's put t equal 1 over x. Okay, so the limit of x, natural log of x, as x is approaching to 0 from right hand side, equal limit 1 over t, natural log 1 over t, as t is approaching to 0 from the right hand side. It gives you limit 1 natural log of t over t, as t is going to plus infinity, because x is going to 0. That's mean t is going to infinity. Okay, so this one, it goes to infinity. Let's put the negative sign outside of the limit. Is okay to do that. Okay, now we have a fraction. In the same time, we are not using the Hôpital theorem. In this case, we have to retry again here, because we changed the first term to this one. Okay, we try this term to this one. So let's try our limit now. If you by plugging infinity into this fraction, it gives you infinity over infinity. It gives you minus infinity. This is infinity. Natural log of t is infinity. With a negative sign, become minus infinity over infinity. This is indeterminate form as well. So let's apply Hôpital theorem in this case, as you have both functions are differentiable, and also you have indeterminate form. Now you are allowed to use this theorem. Okay, Hôpital rule. Let's start now. You have f of t equal minus natural log of t. If you differentiate this one, it gives you f prime equal minus 1 over t. You have g of t equal t. If you differentiate this one, it gives you g prime of t equal 1, right? Now your limit f prime of t over g prime, as t is going to is approaching to infinity, it gives you the minus limit 1 over t over 1. Okay, this is limit is going to infinity. Let's make it very clear. Minus limit 1 over t over 1, t is going to infinity. 1 over infinity is 0. 0 over 1 is 0. So this one is 0. So we found our limit. Now it's easy to find it. Okay? So the limit of natural log of t as t is going to infinity minus, okay, equal the limit of this term 1 over t as t is going to infinity, okay, equals 0. So the limit x, natural log of x as x is going to 0 from right hand side, equal the limit of 1 over t minus the limit 1 over t as t is approaching to infinity is 0. Now we found the limit, okay? This is the final result of this limit. Thank you for watching. I will see you in next video. Bye.